Hello, I'm Hannah, and here's our FiberFone. As you can see, here's the microphone, and here's the fiber connections, and here's our speaker. And if you listen really carefully, you can see that I'm currently talking into the microphone, and over there, I'm coming out of the speaker. Why don't you pan over to our other device so we can see the speaker? Look, there's the speaker. Right here. That's where I would be coming out of. Right here. This is the second FiberFone device. Similarly to the first device, I can talk into the microphone, hello, and it will come out the speaker on the other end. So this is our one FiberFone unit. This one is unfortunately still on a breadboard because of constraints with supplies and everything else, but it is fully functional. It has our transmitter right here. It's these wires here. There's the amplifier for the microphone, the follower for the LED, and here you can see the LED transmitting the signal is here, and then the detector receiving the signal is here, which is attached to our fiber optic cable. And then we have power, of course, up here, and our speaker for this device is right here, which plays back the sound that comes from the detector from the other device. Over here we see our fully assembled FiberFone device. Inside the box is several soldered proto boards that contain the receiver and transmitter circuitry, as well as power. And then on top here we have our microphone, which actually I am transmitting right now my voice through this microphone, which is going out the LED through this cable here. And then likewise, the signal from the other device is coming through the photodetector connection, which is right here. And then we have our speaker right here, where I could listen to the sound from the other person who's talking to me. So now we're going to do a test of different frequencies. I'm going to play a pure sine wave tone off of my phone through the system, and we can see the frequency response on the oscilloscope. This is a 200 Hertz tone. Speaking through the FiberFone. Hello, this is me 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 speaking through the FiberFone.
This is the transmission coupling device. You can see the toslink cable here. We've got the connector adapter. We've got the lens holder, which holds the 5mm ball lens. And then we've got the signal transmitter housing, which isolates and aligns the signal LED to the fiber. Here also we have the signal connector and the photodetector holder, which locks the photodetector axially with the toslink cable and separates the leads for short isolation. Okay, this is inside the FiberFone with the soldered proto boards and the transmission and receiver links. On this side, we have the transmission board with the amplifier chip and the following amplifier and its connection to the LED for transmission. And on the opposite side, we have a proto board with the receiver layout and its connection to the photo detector. The board in the bottom is essentially our power rails that are coming from the laboratory supply.
This is a demonstration of the call, enable, and disable communication between the two microcontrollers in isolation. The green LED indicates that the voice signal is currently being transmitted by the device, and the orange LED indicates that the device is receiving a signal from the other side. From system startup, no signal is being transmitted. When the button is pressed, the device begins transmitting the voice signal, which lights the green LED on the call side and the orange LED on the receiving end. It then waits to receive a signal from the other device. Once it has received the confirmation signal, it will also light the orange LED. The receiver can then press the button in order to enable their voice signal. Once either side has enabled their voice signal, they can then turn it off by pressing the button again.
On the oscilloscope screen, we have the unamplified signal from the codec with a supply of 5 volts. The amplitude is reading 3.36 right now. It's basically between 3.2 and 3. On the oscilloscope screen, we have the unamplified signal from the codec with a supply of 5 volts. The amplitude is reading 3.36 right now and operating at 1.4 megahertz. So here's the un-PC boarded codec, and here's our oscilloscope probe. If we connect the oscilloscope probe to the conditioned circuit for the LED for transmission, we will have the identical signal to the LED, and then at the drop end of the LED we have the remaining 1.76 volts, same digital signal at, again, 1.4 megahertz.
And this is showing sort of a stopped screen capture. You can see how the sent signal is much clearer and more square than what we're receiving, but we believe that this problem will be remedied by having higher performance amplifiers. Thank you for watching our demonstration of the FiberFone.